In this video, we'll solve a variety of compound linear inequalities and we'll write the solutions on the number line and in interval notation.
Here we have two inequalities. 2x minus 3 is greater than 3. 3x minus 3 is less than or equal to negative 21. They're joined with an OR. We're going to solve each inequality separately and then join the intervals with an OR. Let's start with 2x minus 3 is greater than 3. To solve, we're going to begin by adding 3 to each side. That gives us a new inequality. 2x is greater than 3 plus 3, which is 6. Now divide by 2 on both sides, and x is greater than 3 is the result. Now we'll solve 3x minus 3 is less than or equal to negative 21. We begin by adding 3 to each side, which gives us the new inequality. 3x is less than or equal to negative 18. Now we divide both sides by 3, and we get x is less than or equal to negative 6. If we graph on the number line, the interval x is greater than 3 does not include 3, but all the numbers greater than 3. And the interval x is less than or equal to negative 6 does include negative 6, and all the numbers less than negative 6. So we've graphed the solution on the number line. Let's also write it in interval notation. Remember, since it's an OR problem, any part of the number line that's shaded is included in the solution. That's the interval from minus infinity to negative 6, and the interval from 3 to infinity. OR is a union of those intervals. So there's the result in interval notation and graphed on the number line. Here are two inequalities joined with AND. Let's start by solving each one separately. To solve negative 3w is less than or equal to negative 18, we want to divide both sides by negative 3. This invokes the special rule that when we multiply or divide both sides by an inequality, we need to flip the inequality around to the opposite direction. The solution is w is greater than or equal to negative 18 divided by negative 3, which is 6. The next inequality, 2w plus 4 is less than 8, we begin by subtracting 4 from each side. That gives us the new inequality. 2w is less than 8 minus 4, which is 4. And then we divide by 2 on each side, and we end up with w is less than 2. Since we divided by a positive, we didn't need to flip the inequality. To graph the inequality w is greater than or equal to 6, I make a square bracket to include 6 and shade the numbers greater than 6. To graph the inequality w is less than 2, I make a parenthesis so as not to include 2 and shade the numbers less than 2. Since these inequalities are joined by AND, we're looking for places on the number line where both inequalities are true. But since the two shadings never overlap, there are no places on the number line where both inequalities are true. And so the solution to the compound inequality is that there are no solutions. It's the empty set. Here's an inequality written in the between notation. The expression 2x plus 4 is between 2 and 16. If we were to write that as two separate inequalities, it would look like 2 is less than or equal to 2x plus 4, and 2x plus 4 is less than or equal to 16. But we could solve this all in one go, just by treating the two places where there are inequality signs as dividing the inequality into three sides. Our goal is to simplify the expression in the middle so that it is just plain x. So we begin by subtracting 4. But we have to remember to subtract it not just from the 16, but also from the 2. 2 minus 4 is negative 2, so our new inequality is negative 2 is less than or equal to 2x is less than or equal to 16 minus 4, which is 12. Now let's divide everything by 2. That will give us x alone in the middle. We divide 12 by 2, and we divide negative 2 by 2. So now we have negative 1 is less than or equal to x is less than or equal to 6. On the number line, this means that x is between negative 1 and 6. That's this portion that I'm shading that's between negative 1 and 6. Negative 1 is included in the interval, and so is 6. In interval notation, we would write square bracket negative 1 comma 6. X is the numbers between negative 1 and 6, inclusive. Here are two inequalities combined with and. We'll solve each separately. To solve 3x plus 8 is less than 20, we're going to subtract 8 from each side, which will give us 3x is less than 12. Now we divide each side by 3, and we end up with x is less than 12 divided by 3, which is 4. To solve the second inequality, negative 6x minus 2 is greater than or equal to 16. I'm going to add 2 to each side. Now I have negative 6x is greater than or equal to 18. And I'm going to divide each side by negative 6, which should trigger the little alarm bell that tells you you have to flip the inequality. Now is not greater than or equal anymore. It's less than or equal to 18 divided by negative 6, negative 3. On the number line, to shade x is less than 4, 4 is not included, but all numbers less than 4 are included. To shade x is less than or equal to negative 3, all the numbers including negative 3 and less than negative 3 are included. Well, we're combining with and. So what interval on the number line has both blue and red? It's this interval below negative 3 and including negative 3. So the interval from minus infinity to negative 3, including negative 3, fulfills both inequalities.